If you use AI to summarize dense financial documents or pull inventory numbers or analyze complex research, you have probably felt that sudden creeping anxiety.
Oh, absolutely.
Right, you're looking at this beautifully formatted, bulleted summary the model just generated. You see a highly specific, very critical number sitting right there in the text, and a little voice in the back of your head just whispers, "Did you just make that number up?"
Because acting on a silently fabricated number is, well, it's infinitely worse than an AI model just throwing up its hands and refusing to answer.
Exactly. I mean, a refusal is a temporary inconvenience, but a fabricated number integrated into a Q4 strategy, that is a corrupted decision that can cost millions.
Yeah, the stakes are incredibly high.
So welcome to this deep dive. Today we are examining a highly relevant technical concept paper, and it's called Grounded by Construction.
It's a fascinating piece of work.
It really is. Our mission for this deep dive is to explore what appears to be a revolutionary and incredibly rigid solution to the most dangerous problem in AI today, which is, when language models confidently invent numbers that simply do not exist.
Right, the hallucination problem.
Yeah. And to frame what we are dealing with, think about current AI models as an incredibly fast, brilliant intern.
Okay, I like that.
Like, this intern can read 1,000 pages a minute and synthesize themes beautifully, but they are absolutely terrified of admitting they don't know something.
Oh, yeah, the over-eager intern.
Exactly. So if you ask them for a specific Q3 sales figure from a massive, poorly formatted spreadsheet and they can't locate the specific cell, they would rather look you in the eye and confidently guess $4.2 million than admit they failed to find the data.
And we have spent years, I mean, literally years, trying to manage that intern's personality, right?
Right, with prompts and instructions.
Exactly. We tweak the prompt, we offer rewards, we threaten penalties in the system instructions. But what Grounded by Construction proposes is that we stop trying to change the intern and we start changing the physical layout of the office.
Oh, wow.
Yeah. We are moving from hoping the system behaves to mathematically guaranteeing it. And to understand why this shift is necessary, we have to look at why hoping is currently failing us so badly.
So let's talk about that. Why is it failing?
Well, we all know that large language models operate on token probability distributions. They're predicting the most statistically likely sequence of tokens based on their training data.
Which is great for some things.
Oh, it's fundamentally spectacular for drafting a marketing email or translating code. But it is structurally opposed to exact factual retrieval.
Because probability doesn't care about absolute truth.
Precisely. If you ask a model what was paid for line item X, and the model hasn't actually located line item X in your context window, it doesn't naturally trigger an I don't know state.
It just guesses.
It looks at the statistical probability of the tokens it is currently generating. In a sentence about a paid invoice, a confident-looking integer belongs at the end of that sentence. It generates a figure because, well, a figure is the geometric shape of the answer you requested.
That is such a wild way to think about it. The researchers actually tested this, didn't they? With a permanently recurring scenario.
Yes, they call it the line item that wasn't there. It is a brilliant stress test.
How does it work?
You upload a document, like a dense table of real line items from a vendor contract, and then you deliberately ask the model about a software license that does not appear anywhere in the document.
A classic user error, basically.
Exactly.
Yep.
And instead of signaling absence, the model routinely hallucinates a complete, highly detailed reality.
It fabricates two plausible-looking line items, right?
Yeah, it invents specific prices for them. It generates unique identifiers, tracking numbers, alphanumeric UEDs. None of those characters exist in the source text.
The correct answer was just a null value. But the token probabilities dragged the model into creating an entirely fictional subset of data.
Right. And if it can invent a vendor line item from nothing, it can silently invent a profit margin, or a pharmaceutical dosage amount, or a structural load-bearing limit in an engineering report.
Okay, let's unpack this. I mean, why can't we just use better prompting? Can't we just type in all caps, only state figures in the source, never guess?
I hear this argument constantly.
Because I'm guilty of this exact behavior. I have system prompts that read like a hostage negotiation. Like, if you do not know the answer, tell me you do not know. And it works most of the time.
Right, but usually right isn't good enough.
No.
No. Most of the time is an unacceptable standard for a critical operational decision. The paper's key insight here is that an instruction is just a request to a probabilistic system.
A request, not a rule.
Exactly. You are sending a request, not installing a guarantee. Prompting is basically pleading with the model's token distribution to favor accuracy over fluency. No amount of instructional tuning reduces the fabrication rate to absolute zero.
So asking nicely doesn't work.
It doesn't. If you are relying on prompting, you are still operating in a paradigm where accuracy is just a strong suggestion.
So we have to physically remove the option to guess. We have to take the model's token distribution out of the equation entirely when it comes to facts.
We do. Which brings us to the unbending color principle of this entire framework.
And this is non-negotiable.
Absolutely non-negotiable. The AI model must never be the source of a fact about the data.
Wow, okay. So the model can write the transition sentences, it can format the markdown tables, it can draft the executive summary, but it cannot originate the actual integer.
Right. The framework dictates that every single figure a system displays to a user must fall strictly into one of two categories.
Quoted or computed.
Exactly. A quoted figure means the number appears verbatim, character for character. In a source, the system actually read on this specific operational turn. It has to physically exist in the retrieved evidence.
And computed is slightly different, but just as strict.
Right. Computed means the number is the exact result of arithmetic over numbers that are themselves strictly quoted, and the model has to show its work so the math can be independently checked.
So if the uploaded document says item A is $5 and item B is $10, the system can output $15.
Yes, but it has to show the math. Anything else, anything that isn't directly quoted character by character or strictly computed from quoted numbers is defined as ungrounded.
And ungrounded is bad.
Very bad. Ungrounded content is treated as a severe system violation and is blocked entirely.
The mechanism they use to enforce this is so interesting. They use a deterministic verification layer, or simply the gate.
The gate, yes. It sits completely outside the AI model.
It's not an AI itself at all.
Not at all. It runs after the model drafts an answer, but before that answer is ever rendered to your screen. And because it is deterministic, it uses plain, auditable, rigid code.
Like just standard programming.
Exactly. We are talking about exact string comparison and basic integer arithmetic. It scans the model's output tokens, extracts the numbers, and searches the raw source document for a matching string. It requires zero model judgment.
I love this. It's like, okay, if the AI model is a highly creative financial writer drafting a quarterly report, the gate is a strict, joyless compliance officer standing by the door.
That is a perfect analogy.
The compliance officer does not care how eloquent the writing is. They don't care about the narrative flow. They hold the drafted report in one hand and the original raw receipts in the other. If the numbers don't match the receipts exactly, the door stays locked.
The report is burned. The model cannot talk its way past the gate, and the user cannot bypass it.
So if this gate is an unbending compliance officer, what specific AI tricks and failures is it actively hunting for? Because language models fail in highly specific ways.
They do, and sometimes they are incredibly insidious when dealing with numbers.
The paper actually maps out 4 specific phases of failure. Number 1 is the invented figure.
Right. This is the pure hallucination. The model reads the context, realizes it's talking about a budget, and guesses that $150,000 sounds natural. It generates it.
But it's blocked because it isn't in the evidence. The gate intercepts it, scans the source for $150,000, finds nothing, and instantly kills the response.
Exactly. The second failure is bad arithmetic.
This is where the model actually tries to do the math but fails.
Yeah, it finds the 3 specific software licenses, quotes them perfectly, but when it generates the total, the token generation slips, and it outputs the wrong sum. A pure LLM math error.
And it's blocked because the shown components must sum exactly. The gate catches it.
Right. Now, the third failure is much harder for a human to catch. Right number, wrong item.
Oh, this one is tricky.
The model scans the document, finds a very real string of text that says $85,000, and quotes it perfectly. The string matches. But that $85,000 was actually attached to the marketing department's software spend, not IT.
So how does a rigid string matching gate catch a semantic error like that?
By enforcing structural locality. The gate doesn't just check if the number exists somewhere in the vacuum of the document. It requires the model to point to the exact segment of text it is quoting from.
So it's blocked because the figure must sit with the exact item it claims to represent.
Yes. If the model claims it's the IT budget, but the citation points to a paragraph labeled marketing, the gate flags the structural mismatch.
Yep, that brings us to the 4th failure mode, capitulation. This is flipping a figure just because the user pushed back.
This one is fascinating.
Well, I am going to push back on this myself. Is capitulation really a bad thing?
You think it's helpful?
Yeah. If I tell the AI, hey, are you sure about that price? I thought we increased it, and it changes it to agree with me. Isn't it just being polite and trying to help?
What's fascinating here is that capitulation actually destroys trust.
Really?
Yes, human beings are deeply conditioned to view accommodation as intelligence. In social interactions, adapting is polite. But in an analytical system, capitulation destroys the integrity of the data.
I
The
think.
system must value accuracy over agreement. If a user pushes back, the AI must recheck the evidence and report exactly what it says. It has to refuse to invent specifics just to agree with the human. Accuracy must supersede agreement.
So a system that folds to user pressure is basically a yes man, not a tool for objective analysis.
Exactly. It's a harsh reality for user experience, but necessary for an unshakable system of record. And to make this work, the framework relies on defense in depth.
Because the gate doesn't operate in a vacuum.
No, it needs two supporting layers. The first is faithful retrieval. You need to ingest high-fidelity, dense content rather than blurry summaries.
Because a figure can only be quoted if it is actually seen character by character.
Right. You need the raw data. The second layer is generation discipline. You instruct the model to explicitly output its arithmetic operations and citations, making the gate's job easier.
Okay, having this ironclad defense sounds great for accuracy, but it raises a massive usability question. If the system is this strict, won't it constantly block correct answers and drive the user completely crazy?
That is the ultimate usability concern.
Yeah.
A system that frequently blocks correct answers is its own kind of failure.
Right. If the document says 5,000 in words and the model outputs 5,000 in digits, the gate flags a mismatch.
So the gate is designed to be mathematically conservative to minimize false rejections. If a claim is genuinely ambiguous, it holds back, rather than risking a false block.
And the paper has this brilliant internal mechanic, the correction loop.
Yes, this is where it really shines. The user never actually sees the blocked fabricated number.
You never.
Never. When the gate catches a lie, it intercepts the draft at the millisecond level, and it gives the neural network a bounded chance to fix it internally.
So it basically kicks the draft back to the model and says, try again, I can't verify this.
Exactly. The model gets a couple of retries behind the scenes. If it realizes its math error, fixes it, and the sum is perfect this time, the door opens. The response is delivered, and the user is completely unaware a hallucination was prevented.
But what if it still can't find the real number after those retries?
Then it simply gives the user an honest fallback message like, I can't confirm that figure based on the provided document.
That is a very deliberate trade-off.
It is. A blocked but correct answer, or a graceful failure, only costs a sentence of clarification. But a displayed but fabricated number costs absolute trust.
But how do we know this won't break next week? With constant software updates and model tweaks.
That brings us to assurance and non-regression. These guarantees are encoded as automated tests built from real failures.
So they map out the invented numbers and bad math into a massive test suite.
Right. Every time a developer changes line of code, this automated suite runs. It actively tries to force the system to hallucinate. If a future update weakens the guarantee, the build fails before it ever ships. The protection must be continuously tested or it will silently erode.
That is incredibly rigorous. But, earning your trust as a listener means being honest about the boundaries of this technology. And the paper outlines some explicit limits.
Yes, true trust requires total candor about what this system cannot do. The first limit is source error.
Right. It eliminates fabrication, not typos in the original document. Garbage in, garbage out.
Exactly. If your uploaded spreadsheet has a typo and says the server rack costs $5 instead of $50,000, the system will faithfully report that typo.
Because it doesn't have common sense about the real world, but it will cite the source so you can trace it back and see the human error.
Right. The second limitation is that this guarantee only applies to supplied data.
So just the documents or live lookups you provide, not general knowledge about the outside world.
Correct. If you ask for the current interest rate and it's not in your documents, the gate has nothing to audit against.
And the last limit is those rare false rejections we talked about. If the gate is unsure if two numbers are equal, it errs toward asking the user rather than guessing.
Yes, the cost of absolute certainty is an occasional moment of friction.
Which leaves us with a final provocative thought to mull over.
Let's hear it.
We have seen how placing a deterministic code-based gate outside the AI fundamentally shifts the dynamic from persuading a model to enforcing the truth.
That's a huge paradigm shift.
It is. Today, this paper applies that strictly to figures and math. But if we can successfully ground by construction for numbers, you have to wonder what other types of precise, vital information in your business or life could eventually be locked behind a deterministic gate.
That is the big question.
Right. Like, could we verify legal clauses in a contract? Could we enforce medical dosages? We could finally turn AI from a creative brainstorming partner into an unshakable system of record.
It completely changes how we can use these models.
It really does.
Yeah.
Thanks for joining us on this deep dive. We will see you next time.